So this next section is discussing summation notation. Now, if you guys take calculus, this is one of these things that we will see in calculus, and we will use it in calculus. And that's one of the reasons we wanted to cover this with you, just to make sure that you are aware of, the summation notation, how to read it, so that when we have to apply it later on, we can just build on top of this knowledge. So I would like to focus in here. So we can use summation notation to help us describe a series without having to write the entire thing out. So if you notice, it says that S sub n, and I think up here in this notation, it may define S sub n for us. Let's see if they do. Let me get a pen. So if I look here, it says the sum of the nth term of the sequence is called the nth partial sum, and the sequence is denoted as S sub n. So our sequence here, or a piece of our sequence in this case, if we denote this as S sub n, is equal to the summation, right? We have that sigma sign. Sigma lets us know that we are going to, that is our summation notation, telling us that we are going to add each one of these values together. So we are finding the sum of a sequence here from 1 to some value n. So they're going to give us an expression, and then we're going to substitute these values in, and then we're just going to add each one of the products or the outcomes or whatever we get when we substitute in. So I won't do all of these. All of these pretty much work the same way. So maybe we can do 9, 10, and maybe look at 11, just so you don't have to sit here and watch me do so many. But what this is asking me to do, number 9, for example, it is asking me to substitute into, let me change my pen color, into that expression. And my first value that I substitute in will be 1. So this is going to be equal to 3 times 1 minus 8. And then we're going to do that. I'm going to bracket this off. We're going to do that for every number, whole number, from 1 to, and this tells me where to stop, from 1 to 3. So then I would do 3 times 2 minus 8. And then my next or my last term would be found by substituting 3 into that expression, into the place of k. So what that gives me is 3 times 1 minus 8. 3 minus 8 gives me negative 5. Plus 3 times 6 is 2. 2 minus 8 is, 3 times 2 is 6. 6 minus 8 is negative 2. So I had the answer. I was saying it wrong. And 3 times 3 is 9. And 9 minus 8 is 1. So if I write this is really negative 5 minus 2 plus 1. That gives me negative 7 plus 1, which gives me negative 6. And that is the, it says, what is the definition or the directions? Write the terms for each series and find the sum. So negative 6 would be the sum for number 9. If I look at number 10, it looks different, guys. I don't care how complicated these things look, but they all work the same, right? So don't overthink it. They're going to give us an expression, and what we're going to do for each one of these is we're just going to substitute into those expressions. So for number 10, they've given us an expression, and then we're going to substitute starting at 1, and then we're going to end at 4. So this would look like 2 times 1 divided by 1, and that is 1 squared, and then we would have 2 times, I put equals. Let's make sure we write this correctly. Slow down, Latoya. Let's write this correctly. So we have plus 2 times 2 divided by 2 squared, plus 2 times 3 divided by 3 squared, plus 2 times 3 No, we're stopping at 4. We've already did 3. So 2 times 4 divided by 4 squared. And, guys, if we were to, I don't know, we could put this in the calculator, but let's just see if we can simplify this a little bit. This would give us 2 plus, 2 times 2 is 4, 2 squared is 4, so that's 2 plus 1 plus 6 divided by 9. 6 divided by 9 gives me 2/3. And then I end up here with 8 over 16, which gives me 1/2. And if I add all of that together, that is going to give me 25/6 as my answer. So it's not really different than what we did before. The actual expression has a little bit more moving parts, but the idea is the same. We substitute. And then this last piece, number 12, I have a summation notation. I have a constant there. No, I have a 10, right? There's no variable. And we might be quick just to say that it is equal to 10. But what this actually means is that my first term is 10. My second term is 10. My third term is 10. And my fourth term is 10. And a way I could reason with myself to get me to understand why it's 10, is I could almost rewrite this as, let's see if I can rewrite this where it makes sense to us. I could almost rewrite this summation notation as 4 n equals 1. Then I could have 10. Then I could have n to the 0 power, right? Because anything to the 0 power is 1. And then I could substitute those values in, but each time I end up with just 10 times 1, no matter what n is, right? So that's how we could reason with ourselves that n to the first power is 10. N, or my n sub 1, or my s sub 1. In other words, when I substitute that 1n, I get 10. When I substitute 2n, I get 10. When I substitute 3n, I get 10. And when I substitute 4n, I get 10. So whichever way makes sense to you, just understand that if there's just a constant there, then the answer is not just 10. It's going to be 10, in this case, 4 times. Okay? So I think that's pretty explanatory. But if you need some more help with these, I skipped number 11, but it's the same idea. We just substitute in. But if you need some more help with these, guys, feel free to reach out. I will be happy to help.